Okay, so we're ready for our next video, the second one about rational exponents and radicals. Here we go. We need our paper. And I gotta get rid of the pen. And let's go going. So, rational I'm gonna rational exponents, and this little symbol there, and radicals, right? And this is our second one, so I'll call it B. All right, so let's get going. Here's three fundamental things that we need to remember. It's all the same thing, but let me show you three examples. The square root of x is the same thing as a fractional exponent. So what we're dealing right now is, the topic right now, the subtopic, so to speak, is fractional exponents. That's the piece that we're dealing with, fractional exponents. It's all part of rational exponents, but the little piece that we're dealing with right now is fractional exponents. So the square root of x can be put into a fractional exponent known as x as to the 1/2 power. Let me show you a little pattern and you'll see how this works. What if I ask you about turning a cube root of x into a fractional exponent? Cube root of x is radical. Now there's a relationship between radicals and exponents. That's what we're seeing over here. The square root of x is the same thing as x to the 1/2. The cube root of x, you can start guessing it. It's x to the 1/3. The number that appears over there inside the radical is going to be the denominator. The invisible 2 over here is the denominator. And last in the pattern, that's all we need to establish this pattern, is what would we do? How do you convert the 4th root of x into a fractional exponent? It will turn into x to the 1/4. There is the example. That's the concept illustrated with A, B, and C. Okay, now let me proceed to ask a question. Problem number 1. What if I gave you the following question? What is negative 1,000 to the 1/3 power? Now that looks a little daunting at first, but don't forget, the 1/3 power is exactly like saying the cube root of negative 1,000. We just learned in the previous video that if you have an odd root and a negative number, that's no problem. Just figure out what's a number times itself times itself that will be equal to 1,000. 3 times. And if there's 3 zeros, then the answer is 10, but it's not 10, it is negative 10. Negative 10 times negative 10 is 100, and 100 times negative 10 is negative 1,000. There's the answer to this question. Let's go to number 2. What about if I would ask you, it looks like a complicated question, 64 divided by 121, and take that to the 1/2 power. What does the 1/2 power mean? 1/2 power, let's look it up. It's a square root. So essentially what I'm asking you is for the square root of 64 over 121. We had a similar problem in the previous video. The square root of 64 is 8. The square root of 121 is 11. And there's the final answer. Okay, so that pretty much shows you how fractional exponents and square roots are totally related to each other. Now, it gets a little complicated with the next question, and I don't even want to call it problem number 3. It's fractional exponents, but it's different. Let me show you what I mean because it's a little bit more complicated. What if I ask you for 16 to the 3/4 power? It's not 1/2, 1/3, or 1/4. It's 3/4. It's a fractional exponent. It's a fraction. So it's a fractional exponent. But now I've made it more complicated because I'm not asking you for 1/4. I'm asking you for 3/4. Here's how you do it. You do it in 2 steps. Here's the answer. Step 1. You first look at the denominator. It says 4, right? So take the 4th root of 16. Not going to be finished. Just bear with me. This is step 1. What's the 4th root of 16? Answer 2. Step 2, and there's only 2 steps. Step 2, I don't mean equal, I really mean colon. Step 2, take the number 2, right? That was our interim answer, 2, and raise it to what? The numerator power, which is 3. 2 to the third power equals 8. That is the final answer. 16 to the 3/4 is equal to 8 after a 2-step process. Okay, let me have you practice that. Let me show you one. You can always stop these tapes if you're doing them on your own. When we're doing them in class, you can't stop it. I can stop it, but I understand you can't. But when you're looking at these videos by yourselves, you can stop the tape and do the problem by yourself before you see what I do. Anyway, here's the next question. Problem number 4. How about problem number? What did I just do? I meant to call this problem 1 and problem 2. Too late. This is 3. This is 4. It's okay. It's no big deal. Anyway, 32, here's the question, 32 to the 3/5 power. Okay, step 1, I'll call it S1. Step 1, I take the 5th root of 32. What is the 5th root of 32? 2. Step 2, I take that 2 and raise it to the 3rd power. And it turns out to be 8 again. It's fine. That's how it works. You first take the 5th root. You work on the denominator first. Pay attention to the denominator first. Take the 5th root. That's step 1. And step 2, go to the numerator and raise it to that power. This one diminishes it, and the other one raises it. The numerator raises it. Okay. How about problem number 5? Similar stuff. I'm not changing topics on you, or even changing it a little bit. This is going to be very similar, but here it is. Negative 27 raised to the 2/3 power. To the 2/3 power. All right. Step 1, without even me writing S1 and S2. Step 1, take the cube root of negative 27. What is the cube root of negative 27? Answer, negative 3. The cube root of negative 27, negative 3 times negative 3 times negative 3 is negative 27. So the cube root of negative 27 is negative 3. What do I do with that negative 3? I raise it to the 2nd power, the numerator. Negative 3 to the 2nd power is equal to 9. Negative 3 times negative 3 is 9, and the final answer is 9. That's how you deal with these type of fractional exponents. 2-step process. 2-step process. 2-step process, and I did these 2 steps a little bit quicker. I took the cube root of negative 27 first. That would be negative 3, and then I squared it. Negative 3 squared is equal to 9. That was the 2nd step. Okay, here's some more stuff. It's the same topic. We're not changing topics, but here's some more stuff about this. What if you were given on your paper, and I think I've seen this on tests in the past, and you were given on your paper and you're just staring at x to the 3/7 and you're wondering what they want from you. X to the 3/7. So here's what they want you to transform it into. They want you to turn it into a radical. Okay, most of the time they'll tell you exactly what they want. Sometimes they might just put it there and give you a bunch of answers and you got to figure out what they want. But most of the time they'll tell you what one is. At least that's how the course was working last semester. I'm assuming that the people who control this course are not changing it. Okay, and not changing it radically or drastically. So what do? You take the 3, the numerator, you put right next to the x in the upper right hand corner, and then you create a root for it. And guess what you put? The denominator in there, the 7th root of x cubed. So the denominator of a fractional exponent belongs as its root, and the numerator belongs as its power right next to the base. Base to the power comes from the numerator. The root of it comes from the denominator. What if we had to go in the opposite direction? What if they gave us the 4th root of x to the 3, and they wanted us to change this into a fractional exponent, right? They gave us instead this, we went from fractional exponent to radical. Now we're going radical. They want us to change this into a fractional exponent. So there's a fractional exponent has a numerator and denominator. Where does the denominator? What number goes in the denominator, and what number goes in the numerator? So the 4 is the root that's always going to go in the denominator. The root will always go in the denominator. And the power right next to the x will go into the numerator. And there we've converted this radical into a fractional exponent. Okay, we still have some time on this tape. So let me move the chains here. Let me move this upwards. Let me see if I can get that to move. Yes. Oh, I have hardly any room. But I want to at least show you an example of where we need to go in the next video. And this time, I'll call it problem number 1. This time I'll call it problem number 1. I might as well. And we're dealing with this topic. We're not changing it on you. But what if you're staring at it, and I don't know if I'm going to do it in this video or the next, but let me just show you the problem. X to the 4 sevenths, x to the 4 sevenths, times x to the 2 sevenths over x to the 1 seventh. X to the 1 seventh. So we're going to have to go back to remember those fundamental rules that I showed you, x to the second times x to the 4 times x to the second, or x to the 5 divided by x to the 3. We're going to have to use those rules for fractional exponents. That's where we're going in the next video. I'm going to stop it here. We don't have enough room. I need to put it up on the next video and clearly, etc. Okay, so let me put a stop to this, this video here, and we'll go on to the next.